Okay, I didn't promote that because I didn't have a link. Some people, complain that they don't have iPhones.
If you go to my Twitter, you'll see the link. You can retweet it on your account. It's been quite a challenge to get this to work, but we are doing our best.
That's great that you did that, so that we can get everybody else who don't have an iPhone. It's wonderful. Let me see. I'm doing that right now. I know we're live. Hello, everybody there.
We are live.
Yes, we're live and alive. Which is
gonna put some background music on just for a few minutes while people join the room. Okay?
Okay, great.
Hey, can you hear me, everybody?
We can hear you loud and clear.
Rock and roll. Okay.
We're going to put some background music just for a few minutes while other people join the room.
Yeah.
I'm going to pause that. Welcome everybody to the Longevity Biotech Show. Very special guest today. We have Aubrey de Grey. This is a show where we interview scientists, entrepreneurs, thought leaders, advancing the state of the art in longevity biotechnology and how this is going to impact us and the world in the decades directly ahead. I'm Robert Zimin, your co-host with Nathan Cheng. What we're going to do is we're going to have 1 hour, a few minutes of intro, about 25 minutes of prepared questions, 25 minutes of audience questions. a few minutes of lightning round closing, and then we're going to have an open-ended chat for as long as people are willing to go. So just hold your questions till the half-hour mark. Also, we are live streaming at the moment. This is being recorded. That's what the red button is in the title. It was quite a challenge to figure this out, so this is being done in a kind of a funny way. I'm just I have my mic open on the laptop here, which is going to the live stream, and the speakerphone from my phone is going to feed into that. So just bear with us if we have any technical difficulties here. So with that, maybe we can go into the introductions and get on with the questions. Nathan, you want to go first?
Yeah, sure. Thanks, Robert. So my name's Nathan. I'm the founder of longevitymarketcap.com. And there's a newsletter there where I just go into some of the developments in the longevity biotech industry. And I'm also the founder of longevitylist.com. And that's a place where you can go find jobs, companies, and investors in the longevity space. And I'm super happy to be here today. Aubrey is a bit of a personal hero of mine, so I'm very humbled to be here. Thank you.
Great. How about Maria, and then we'll finish with Aubrey.
Hello, I'm Maria Entraigues-Abramson. I'm Global Outreach Coordinator for SENS Research Foundation. I've been working with Aubrey for about 15 years or something like that, maybe a little more. Before SENS was Methuselah Foundation, and we work, well, you know what we do, or most of you do know, we develop therapies to get aging under medical control, and we're trying to change the way that aging is being researched and treated. I am also a singer, songwriter, and a private pilot. And thanks so much for having me here.
Great. I mean, Aubrey, you're the main guest, so I don't know how much of an interim background we need for you here, but maybe a quick few seconds.
Sure, yeah. So, and I hope my connection is good enough here. It went down for a few seconds a moment ago, but so I'm Aubrey de Grey. I'm the chief scientist of SENS Research Foundation, which you just heard about from Maria. And really the foundation was created around the ideas that I started putting forward about 20 years ago that essentially revolve around a new way of dealing with aging as a medical problem. Back then, insofar as anyone thought that we would ever be able to do that, it was at the level of trying to slow down the rate at which the body damages itself in the course of its normal operation. And I was the first person to put forward the idea that actually it might be easier to repair the damage preventatively, before it actually gets to be abundant enough to make you sick, but not to try to slow down the rate at which it is generated. And this is now a very mainstream concept. It took a while to get that way, but of course we're not there yet. We haven't developed those medicines yet. Some of them are very much on the way and are being pursued very aggressively within the private sector now, which is fantastic. But others of them are not that far along and are still very much the domain of the non-profit world in the form of SENS Research Foundation.
Right, so we're going to get into some of the detail there shortly. So also a bit about myself. I am I work in aging biology research right now in a lab in Quebec in Canada. I've worked for almost 10 years as a research software engineer and bioinformatics programmer, and now trying to get into the longevity biotech space. So why don't we just get right into it then? I guess the first question here for you, Aubrey, is how did you get interested in the whole idea of longevity way back?
Sure. So there are two answers to that question. One is, how did I get to realize that aging is a really important problem, perhaps the world's most important problem? And the answer to that is, I don't remember, because I can't remember a time when I didn't know that. I grew up same way. So the other way of answering your question is, when did I discover that, and what with the consequence of becoming a gerontologist? And that was really late in life. I was probably getting on for 30 years old by that time. It happened as a result of meeting and marrying a biologist and realizing painfully slowly that we were never talking about aging, and starting to ask questions and discovering that actually even biologists, let alone the general public, actually thought that aging was not very interesting and not very important. And so, having spent several years by that time being a computer scientist working in artificial intelligence research, I decided, well, I had to switch fields, and I was in a very fortunate position where I was able to do that and created essentially a new career for myself in my spare time. And so, here we are.
So, what was it like in the beginning when you were first getting started with everything that you've done? I guess it was around the late 1990s, early 2000s. What was it like back then?
So, again, this is a question I want to give two answers to, because the situation in the first 5 years or so, let's call it 1995 through to 2000, was very different from the situation in the subsequent 5 years or so. In the first 5 years, I was this newcomer, came out of nowhere, and I was just learning. And I was publishing, ideas, and I ended up being able to rise to a pretty good level of, prominence and authority and general respect in the field very quickly. Essentially because I was having ideas that people liked and that they thought they should have thought of themselves. And I was, making a nuisance of myself, asking, hard questions at conferences, and generally doing the thing that tends to result in getting respected. So that was all great. But then I came up with SENS. I came up with this big paradigm shift that I just mentioned earlier on. And for at least a few years, almost nobody understood a word that I was saying. And I'm not really blaming them for that. It was it was a big paradigm shift, and it's normal for that to take a while to be communicated. But yeah, so there was a period of quite considerable acrimony, actually, over those years. But then, once I kind of, won the argument, so to speak, the dust kind of settled, things kind of reverted to the situation of, people really appreciating that I had useful things to say. And more than that, by that time, of course, I had a bit of a fan following in the wider world, and I was able to make quite a difference in terms of actually bringing new money into the field from people who had never really considered that there was much sense in actually funding this kind of research. Initially, of course, it was purely philanthropic. It's been only the past 5 years or so that it started to broaden into the private sector.
So there's a lot of detail there, obviously. I guess you already talked about some of it and how you learned about aging biology and everything. What is the hardest thing about what you do or what you've done in your experience?
Yeah, very interesting way of asking the question, actually, because it's a hard thing to answer. I mean, I guess I always knew, even when I got into the field, and part of the reason why I decided to switch fields was because I know that I'm good at working on hard problems. I'm good at, figuring out how to address them. So I wouldn't say that the scientific advances and the proposals that I've made have necessarily been difficult. The thing that's been difficult is the outreach side of things, going out to the general public and, trying to get them to understand what I'm saying, why I'm saying it, and why it's important. Because at the end of the day, both of those things have always been how I have viewed my role. I'm not in this to discover things for the sake of discovering things. I'm not in it to make money or become famous or anything like that. I'm in it to save lives. And that involves not only figuring out how, but also making it actually happen, getting these therapies developed and disseminated, which of course definitely involves not only convincing scientists that I am talking sense, but convincing the world in general
Right. So, I mean, when trying to persuade or communicate to the general public, what is it that you find to be the biggest challenge in, like, what is their biggest objection, or what is it that's difficult to communicate to them?
Yeah. There is no one answer to that question, because the thing is, the objections ultimately arise from fear. People don't want to hear good answers to these questions. And the reason they don't is because they are petrified of getting their hopes up. They know, as you and I do, that aging is absolutely ghastly, and that it's something that we can't yet avoid, and that people have been trying and failing to figure out how to avoid it since the beginning of civilization. So, it's reasonable to be skeptical when the next person comes along and says he thinks he knows how to fix it. But equally, you've got to find some way to get on with your miserably short life and make the best of it, rather than being preoccupied by this terrible thing that's going to happen to you. And a very good way to do that is to trick yourself into thinking that actually aging is some kind of blessing in disguise, or that it's kind of so woven into the fabric of the universe that it's kind of off limits to medicine. And exactly how you trick yourself into thinking these completely false things doesn't matter, just as long as it succeeds, so long as you do trick yourself. So it's a psychological issue. And I guess I'm not a psychologist in the first place, but also, even if I were, I don't think there really is an open and shut fix to that, a way to do it. People are just inherently going to be resistant.
Well, I guess that's something that we're here to talk about. I got one more question. Doesn't really have a short answer, I guess, but I'll ask it and then I'll pass it over to Nathan. So the other night, I hosted sort of an impromptu room on the platform here on Clubhouse, where I asked in the title, "Do you want to live forever?" And there were, caught quite a few fish, and there were some very interesting responses in the among the people that spoke. One of the themes that came up quite often was people have a hard time envisioning what a post-aging future might look like, or what a very, very long life might look like. What is your vision of that kind of thing, of the future, without aging?
So, yeah, you're right. It's not easy to give a short answer to this, but it is easy to dissect the question in a manner that may be productive. The key thing that I always have to spend my time reminding people of whenever this kind of topic comes up is that longevity is not what we work on. Not at all. We work on health. We're interested in doing medical research to develop medical treatments that will keep people healthy at a time of life, in terms of how long ago they were born, when they normally would not be healthy. And that is all. So all the longevity aspect is purely a side effect. And the reason why it's so useful to start there is, first of all, because health is not controversial. Nobody says, oh dear, maybe it'll only be for the rich, therefore let's not develop a cure for Alzheimer's disease. But also, because it helps one to understand what a world could be like that didn't have aging anymore. Essentially, a post-aging world is one in which you've got a lot more people who are chronologically old, but you've got basically nobody that is biologically old. And that's a very much better world by any definition, because, let's face it, being sick is no fun. Being chronically sick and just getting progressively sicker until you die is very no fun. And having a parent or a loved one who's in that state is also no fun. So, if one starts from that, which is really the only thing we know, right? Because we don't know stuff like, how pensions are going to work or how inheritance is going to work. We're going to make that up as we go along. If we remember the health aspect, then it's much easier to see that this is actually going to be a better world than today.
Okay, fair enough. I noticed one question in the audience. Again, just a reminder for everybody, we're going to have questions open up in 15 minutes or so. I'll pass it over to Nathan now to ask some more questions.
Yeah, thanks, Robert. So Aubrey, This is a great pleasure to speak with you, because you're definitely a big hero of mine, and definitely a big reason why I got into longevity in the first place. I think a lot of people credit you for that, at least in my peer group. And so I guess my first question is regarding outreach. So you were talking about how our main goal is to extend health, right? And not, scare people away talking about, too many things about transhumanism or, lifespans to 1,000 years or whatever. So I've noticed when people reach out to me, a lot of them are interested in like wellness and biohacking and that sort of gateway drug to longevity, like extending health. I was wondering, because I see you get onto a lot of these sort of talks and Zoom calls with other people who are sort of going down that route, approaching longevity through a wellness and biohacking way. I was wondering how you think about engaging that community and like getting their passion and interest in like wellness and like translating it into also thinking about future technologies that will extend health even more robustly.
I mean, my take is it takes a village, right? I mean, everyone's got their own priorities, their own attitudes, their own comfort with risk, their own risk aversion level, and so on. And I don't have any strong opinion about which of what kind of attitude of that kind of way is right or best. To me, it's all about getting more and more people to understand the promise of a post-aging world and the plausibility of it. And, that ranges across the board, from getting people who are fairly enthusiastic to be a bit more enthusiastic and maybe start donating to the field or investing. It also is at the other end of the spectrum, getting people who are, viscerally opposed to this to realise that actually they have no right to be so opposed, and to, if not become supporters, at least shut up and not get in the way of people who are trying to get this done. For me, I work with everybody. I just want to help people to have a better understanding of what we're trying to do.
So, Nathan, if I may, would like to make a comment on this. Yes, definitely biohacking, staying as healthy as you can, it's very important. I'm one of those myself, and I have, all the wearables that you can wear, measuring all my biometrics and trying to optimize my health as much as I can, because I want to stick around until the kind of therapies that we're working on will be available to control aging, which will keep advancing and damaging your body no matter what you do. So all this other stuff is really important, but at the same time what we're working on is on something that will not be stopped by any of these other interventions and lifestyle changes that we are making. So it's really, they are together, but at the same time they are separate things.
Yeah, definitely. Another question about like perception of longevity. So, you and I, everybody in this room would agree that aging is probably the biggest problem, right? That humanity faces. But compared to how much global wealth, I guess, $400 trillion is allocated towards this problem, it's definitely not commensurate. So I was wondering, what do you think is the problem? Like, why isn't SENS or all these other, startups, why aren't we swimming in money? Why aren't people throwing money at SENS?
Yeah, I mean, there are irrational reasons of the sort that I've already touched on, and there are also somewhat rational reasons. In medical research in general, or indeed in any pioneering area of technology, there's a process, a pipeline, getting from the concept to the eventual product. And that pipeline consists of a sequence of steps, each one of which, so we say D earliest stages will be the hardest stages to attract financial support for. Now, of course, against that is the case that the later stages tend to cost more, and certainly in medical research that is very, very true, that like phase 3 clinical trials are very expensive indeed. But psychologically, and indeed, to be honest, financially, that does not necessarily outweigh the de-risking aspect. So, I mean, I can kind of illustrate this perhaps with an account, a summary of the efforts that a number of my colleagues in gerontology tried to make 15, 20 years ago under the banner, under the moniker of the longevity dividend. So what these people were trying to do was to persuade policymakers and politicians in the US that the bang for the buck of putting proper money into research for the postponement of health conditions of late life would be just astronomical. But unfortunately, they didn't really make the whole case. They made the case that if there is even a small amount, like I think they were looking at 7 years of postponement of chronic diseases of aging, then they did some calculations and they figured out how economically beneficial this would be, and the numbers were just, eye-popping, as you might expect. But what they didn't do was actually give any real reason why politicians should believe that putting this relatively modest amount of money into aging research, the people were talking in the region of, $1 billion or something like that per year, a small amount really, why that would actually have any, more than zero probability of delivering any actual any actual progress, any actual postponement of the health problems of late life. And that meant, of course, that the people, their audience, were terribly polite and courteous, but they actually didn't do fuck all. They, they had no impact at all on public policy by this initiative. Now today, things are different. It's very hard, in fact, impossible, to make a scientific case that, that research in aging will certainly fail to have any impact on health. And therefore, a kind of renewed version of the longevity dividend initiative may actually have some chance of success. But even then, it's still difficult because, the politicians in question, they're not scientists, and they're still living in this past world of assumption that actually there is zero chance of any progress. So that's why it's so important for people like myself, and indeed a lot of people, to get out there and say, no, you've got to actually listen to the science. This is no longer science fiction, it is science foreseeable.
Yeah, that sounds a lot like, pretty much like a bet on convexity, right? Like it's, if you put just even a small amount and bet it towards, research or investing in these longevity biotech companies, then, the downside risk is small, but, the upside could be just tremendous, enormous. And I feel like this really relates to like Bitcoin as well, because, as an analogy, back in the earlier days of Bitcoin, people would say, oh yeah, maybe you just invest just 1% of your net worth into Bitcoin, and if it, Bitcoin goes to zero, then so what? And then it's nothing. But then, if it really takes off, then it could be just the upside could be really tremendous. And so I wonder if you've noticed a lot of people in cryptocurrency, right, and Bitcoin, supporters of Bitcoin, Ethereum, etc., they tend to gravitate towards this idea of life extension and longevity, extending healthy lifespan. I know that you gave a talk at one of the biggest conferences back in the day. It was a cryptocurrency conference. I think it was Consensus or something. I was wondering if you can comment on why you think there's such a huge overlap between cryptocurrency, supporters and longevity, because I've noticed it myself.
Sure, and you're not exaggerating. It is huge, the overlap. I mean, I've spoken at a lot of crypto conferences, and I am pretty much always the only speaker who is not speaking about crypto or blockchain in one way or another. And I'm there because because there is so much interest in this work. So why is that interest? Well, I think it's simply a kind of, perhaps it's the extreme example of something much more general, namely that tech people get it. People who have backgrounds in maths and physics and computer science especially, they understand, I guess they're just more comfortable with abstracting and extrapolating and, using actual logic in in a context where other people may think, they can't see anything wrong with the logic, but it just doesn't feel right, and therefore they choose not to believe it, which is the attitude that is more common in the rest of society. Yeah, and especially within the crypto world, it's very clear that it's the more technically minded people, the people who are pioneering particular innovations within blockchain and so on, who are at the absolute pinnacle. So, of course, the most celebrated example is Vitalik Buterin, who created Ethereum, and who has been a major donor to the SENS Research Foundation for a few years now. But he's by no means the only one at this point.
Yeah, I have my own theories about why there's such an overlap. One hypothesis that I have is that Bitcoiners believe that Bitcoin is a solution to the progressive decline of the purchasing power of your savings in your bank account, and longevity biotechnology is sort of like a solution to the progressive decline of the integrity of your body. But that's just my sort of crazy speculation. But while we're talking about cryptocurrency, I have to ask this question. Okay, so SENS Research Foundation, the longevity of the organization itself, like the mission could be another couple of decades or so before we even get to longevity escape velocity, and then even then, when that's attained, we still got to work on extending the runway. The work won't be done at that point. So for an organization that has such a long potential lifespan, you have to sort of think about the black swans and the unforeseeable sort of chaotic events of the future that might affect the longevity of the organization. So I'm wondering if you've ever considered putting 5% of SENS's treasury into Bitcoin.
So, there are a couple of answers to that. The first answer is we're not legally allowed to do that. We receive, of course, donations in cryptocurrencies all the time, but one of the legal restrictions that arise from being a 501c3 public charity is that we're not allowed to speculate, and speculation is defined so as to include essentially keeping any significant amount of money in the bank in any currency other than the currency that we spend most of our money in, which is of course US dollars. So whether it's a fiat currency or a cryptocurrency, we have to convert it to US dollars in a matter of weeks at the worst, or else our auditors get pissed off with us. So that's the narrow answer to your question. But the broader answer is that we don't really think about the organisation in quite the way that you're kind of describing. The way that you're describing it is a bit like the way that, for example, Alcor would have to think about it itself. Their whole business model absolutely depends on the company never going bankrupt. But with us, it's not really like that. In fact, it's perfectly plausible that within even as little as, let's say, 5 years from now, we could decide that a 501c3 public charity does not have much of a role anymore in spearheading all of this, and we might reinvent ourselves in a completely different form. Anything can happen, and we're totally open. We're always, open-minded about what the best thing is to do in that kind of way. I certainly feel open-minded about it. I over the past 5 years have, ended up being spending a lot of my time in the private sector in an advisory capacity. I'm on Christ knows how many scientific advisory boards. I spend a lot of my time introducing families to investors and investors to each other and so on, despite the fact that it's not my background at all. It's just that I happen to, I'm the top Google hit. So, I don't think we need organizational stability as a priority.
Okay, yeah, that's interesting. Robert, did you want to open up the floor for questions?
Yeah, we might as well get started on that because we don't have too much time until top of the hour. Just reminding everybody, this is being recorded, so don't say anything that you wouldn't want to say in public. So we got two people with hands raised. We'll bring you up and you can ask your question, and then maybe just to keep the panel clear for now, we'll bring you back down to the audience in the next hour if we have, if Aubrey and Maria have time. We can just bring everyone up and have an open conversation. All right, let's start with Marianne. You've been waiting for a while. Inviting you to the stage. I'm going to invite other people as well. Just wait. We'll try to go in turn here.
Hello. Thanks for bringing me up. I'm a computer scientist, and I appreciate your mission. So you're definitely onto something there, Aubrey. My question is, what is I should track back a bit. You mentioned how Bitcoin is a solution for a particular problem, and that's what it's advertised as. So, what is the solution that you have found, or that you are trying to find in particular? And also, what have you managed to achieve in the last 5 years? And then, what are you planning to, or what are you hoping to achieve in the next 5 to 10 years? And my question really comes from the fact that if you advertise, the achievements that you managed to make so far, with the limited funding and everything, and then that might help get people onto the mission.
Right. Well, okay. First of all, remember, I wasn't the one who said that cryptocurrency is a solution to something. It was Nathan, I think. Really, to answer your question, I think it is absolutely very important for us to be trumpeting and promoting the progress that we've made. And when I say we here, again, I mean not only SENS Research Foundation per se, but also the community more generally. And indeed, it's by doing that we got where we are now, with the private sector getting so involved with this, rapidly, exponentially increasing number of startup companies and investors getting involved. They're getting involved not just because they are doing venture philanthropy, trying to help the mission. They also genuinely want to make money, and they feel they can. And this is because of the progress that's already been made. We have a very distinctive way of doing things in SENS Research Foundation when it comes to publicizing our work, which is that we publish in the academic literature, but only when we're ready. There is a very, very unfortunate phenomenon in academia, throughout the whole of academia, and this has existed since the dawn of time, called publish or perish. Basically, that the only way that you get your next grant application funded is by having a bunch of objective evidence that you can present to the people who are making the decision whether to give you money or not, and that comes down at the end of the day to whether you have published a whole bunch of stuff in high-profile journals. But unfortunately, what that results in is an enormous bias in favor of doing stuff that is fashionable and sexy, and especially stuff that's easy, so that it can get published quickly. And of course, that is antithetical to the mission that we have, which is to do the stuff that's not being done, this hard stuff. So we absolutely publish when we're ready, but we do not decide what research to do on the basis of a need to publish, and that is critical for us. But yes, we're out there all the time, talking about what we've been able to do, and we're very proud that we have been able to kickstart entire research areas, time and time again, that people had thought were completely impractical.
I guess I should maybe rephrase the question. Would you be able to give examples of the things that you're proud of that you've managed to achieve so far, maybe in the last 5 years, And then, for the next 5 years, 5, 10, what's the...
So, where shall I start? Well, we've spun out half a dozen companies over the past 5 or 6 years as startups, and each of them came from an advance of one kind or another. Just to pick one that is easy to describe, Revel Pharmaceuticals. That is a company focused on restoring the elasticity of various tissues. This has cosmetic applications in terms of wrinkles, and it also has life-threatening applications in terms of hypertension, because the same chemistry is essentially involved, whether it's in the skin or whether it's in the major arteries, or indeed for that matter in the lens of the eye, causing us to have presbyopia. The work that this came from was funded by us for a number of years at Yale University, and it was focused on trying to find ways to break the chemical bonds, the very unusually structured chemical bonds that accumulate throughout life in our tissues and that cause them to become less elastic. This was, something that people have been wanting to do for like 20 years, but everyone had given up on it because they basically just decided the chemistry was too hard and it just wasn't going to happen. And we said, screw that, we're not giving up. We funded this group at Yale purely philanthropically for, I'm going to say, 6 years, something like that, and they cracked it. They didn't crack it all the way, but they cracked it enough to be able to go and actually get investment from people who want to make money. So that is now a company, and it would never have happened if it hadn't been for us.
Okay.
I had a question in your book.
Sorry, Toby. Sorry. We're going to try to go in order here.
Sorry.
No worries. Also, there is someone with a raised hand in the audience. I tried inviting you up. It's not working. Maybe if you leave the room and come back, it'll get fixed. Let's go to Idan. What's your question?
Thank you very much. Hi, Aubrey. I read your book, Ending Aging, a long time ago. Just want to say that I appreciate your work a great deal. I've done evolutionary biology work, not specifically on the evolutionary biology of aging, but relating to it. The idea that aging has been programmed, that is targeted by natural selection, was first advanced in 1881, fell out of favor, has become increasingly back in favor. Many ideas in the history of science have been rejected and then reconsidered decades later. Programmed aging may very well be one of them. My recent work suggests aging may indeed be programmed and may actually be an example of genetic bandwagoning. There's a lot of other work suggesting theoretical and empirical aspects of aging are consistent with programmed aging. My question to you is, insofar as there's increasing theoretical and empirical support for programmed aging, how would that change the way you go about the problem of aging? Thank you very much again.
Yeah, sure. So first of all, I'm sure that most of the audience here is not as familiar as you are with this question. So let me give a moment of background for everybody else's benefit. So when people talk about programmed aging, what they mean is something very specific. What they mean is the theory of programmed aging is the theory that the genome contains genes whose selected function is to cause us to get sick. In other words, if we didn't have those genes, we would stay healthy for longer. We would take a longer amount of time, if we ever did, to actually exhibit the health problems of late life, the progressive chronic condition. Now, that needs to be spelt out because, of course, we certainly know that longevity is determined by our genome. That is why we live longer than mice. But, and even within a species, there is a significant amount of heritability of individual lifespan. But programmed aging doesn't talk about that. It's talking about whether there are genes whose selected function is to kill us off at some age. And so you're absolutely right, of course, that this was put forward in the 1880s by August Weismann, and it was uncritically accepted by pretty much everybody for about 60 or 70 years, until Peter Medawar came along in 1952 and said, hang on, there's a bit of a problem here, which is that in the wild, hardly any individuals actually die of aging. Therefore, there's no selective later, a guy named George Williams came along and did a bit better. But basically, this is now as good as universally accepted. Now, when you say that this idea of programmed aging is coming back into at least the realm of the worth discussing, you're actually not correct. What has come back, or rather has been kind of, restated in a more modern way, is the same idea that was put forward by George Williams in 1957, the idea of what's called antagonistic pleiotropy. And the modern way in which it is being described is something called hyperfunction. There are other words that are being used. Essentially what this says is there are certain genes whose selected function is relevant in early life, especially during development, but which have a negative, a detrimental effect on health late in life. But the detrimental effect emerges so late in life that evolution has not taken the trouble to invent mechanisms to turn the genes off. And therefore, they stay on and they're bad for us. This is a perfectly plausible concept. It's very, very strongly within the original paradigm of antagonistic pleiotropy, and it is absolutely not any kind of reinvention or restatement of the concept of programmed aging, and it must never be understood as such.
Does that answer your question?
Well, Aubrey, I accept your answer. We do disagree, but thank you very much for your response.
Thanks for the question also. Let's go to Ryan. What's your question?
Hi, thanks. I was wondering, I know there's some philosophical differences when it comes to this line of thinking, like some people getting super into intermittent fasting, etc., all that sort of stuff, and others are not, and more focused on the more cutting-edge technology that's coming out. But I was wondering, are there any scientific differences that you think are worth highlighting in terms of people in the field where you think maybe they're just not right, or maybe just some interesting facts or quirks about being so embedded in this line of research? And secondly, not to get too far off topic, but as someone who deals with an organization that accepts cryptocurrency and legal implications, I was wondering if you had any thoughts on the long term of privacy preserving currencies and the implications of what would happen with organizations like the one you work with when they become more mature. Thank you.
Well, let me answer the second part first, because my answer can be very quick. Namely, I haven't a clue. I honestly don't think about that at all, and I certainly don't view myself as having any actual expertise in that area. So I don't have an answer for you on that. On the question, the first part of your question, which is essentially, are there any major differences of opinion within the expert community in gerontology that should be highlighted? The answer is really there aren't very many. There are differences of emphasis, but that's not the same thing at all. So, as I just mentioned to Idan, there really is basically nobody who actually believes that aging is programmed in the sense in which that term is normally used. The people who talk about hyperfunction and such like are not saying anything that is actually in dispute with people who don't talk about it. There are differences of emphasis though. So one of them revolves around things, and you mentioned intermittent fasting, revolves around calorie restriction and everything around that. Calorie restriction mimetics like rapamycin or resveratrol or NAD supplements. All of these things are essentially focused on the same aspect of aging, which is the fact that metabolism is tuned to adjust its priorities according to the availability of nutrients, of macronutrients. This, of course, was discovered nearly a century ago. People discovered that if you feed mice or rats a good deal less than what they would like, but not too much less, then they live considerably longer than they otherwise would. And of course, this has been massively studied. There's still a bunch that we don't know about how it really works. But one thing nematode worms that live a few weeks, you can multiply their lifespans by a factor of like 5 by this kind of thing, by starving them in just the right way at just the right time in their lives. Whereas you can't do that with mice. You can get a factor of maybe 1.5 with mice. And that's still not nothing, it's not nothing at all. But the thing is, if you go up to like dogs, you get 10%. If you go up to monkeys, you'll get a couple of percent if you're lucky. So, and furthermore, this also has a very clear evolutionary explanation, essentially revolving around, again, mutation selection balance. The fact that short famines are frequent enough to come to the attention of evolution, shall we say, to cause evolution to actually, adapt and optimize metabolism in response to them, whereas long famines are just too rare for that. So basically what we have is a phenomenon where in the human context, as far as we can tell, we will get almost nothing in terms of longevity from any of these tricks, whether it's actual calorie restriction in any of its forms, intermittent fasting, etc., or whether it's pharmacological emulation of it. But that's okay, because everybody does see that there is an impact on health span, on resilience, generally on a lot of aspects of health. So, someone like myself, I don't work on that at all. We're interested in damage repair, not in making the body run more cleanly, so to speak. But that does not in any way mean that we look down on that kind of work. These things go hand in hand.
Jesus Christ. Whoops, I accidentally left the room there, trying to get back in. All right, let's go to Toby now.
Yeah.
Yes. Sorry about that.
It's okay. In your book, Ending Aging, I remember reading it about 7 years ago. The one part that really stuck out was the last part of the plan that involved bone marrow transplants every 10 years. Is that still part of how SENS is thinking about extending lifespans, like the actual interventions that you need to do to extend that healthy lifespan?
Yeah, probably not. But for a good reason. So what you're referring to is part of the thing that I have historically called WILT, whole body interdiction of lengthening of telomeres.
Yeah.
And this is the approach that I put forward starting in 2002 at WSA. I wrote about it 5 years later in the book, for addressing cancer in a truly universal way. I have always viewed cancer as the single most difficult part of anything to fix. Somebody is typing and they are not on mute. I think it's Toby. So this is an idea that I came up with as a way to truly universally address cancer, which is really hard because, again, this is an evolutionary thing. Cancer is the only aspect of aging that truly has natural selection on its side, and that makes it uniquely difficult to address. But now we're in a rather interesting position. So the problem back then was I was trying to address the fact that, exploit the fact that cancers need to maintain the length of their telomeres, the ends of the chromosomes, and we might be able to stop them doing that, but we would have to which again is now a startup company. And it's all about essentially using telomerase, the enzyme that 90% of cancers use to maintain their telomeres, using it as a way to kill cells quickly, not just by telomere shortening. Essentially, this group of tactics developed a drug that turns telomerase into a suicide gene, so that when a cell is expressing a lot of telomerase, it kills itself quickly. And the mechanism is very well understood. The therapeutic index is also really good. In other words, we can expect to kill cancer cells really thoroughly with a much smaller dose and duration of this drug than would have any big effect on stem cell populations in the blood and so on. So that is, to my mind, the single most exciting thing in cancer therapy right now. And I want to emphasize that this is the kind of thing that's happened. People often say, well, why don't you write a new edition of Ending Aging? And the fundamental answer is because the only things that have happened that are surprising are good things, things that make our job easier and provide shortcuts to make these therapies less difficult to develop. Of course, there are very generic ones like CRISPR that have also come along in the meantime. But what we have not had is any bad surprises. We've not had anyone come along with a new type of damage, category number 8, that needs a whole new type of therapy. We haven't even had cases come along of reasons why the therapy that was proposed in Ending Aging is now known to be much harder to actually implement than we thought it was back then, and therefore we need to, think of something else. None of those happened, which means the paradigm of damage repair is really strongly standing the test of time.
Awesome, thank you.
All right, we got a few minutes until the top of the hour. We'll try to get another 1 or 2 questions, and then Aubrey, Maria, do you have time past 5 p.m. or 2 p.m. your time?
Yeah, I can stay on for another 15 minutes after that.
All right, so we'll try to get to a few more questions then before our open-ended chat. So, Victor, let's go to you.
Hi everyone, my respect to Aubrey and all of us. I have one interest. You hear me? Yeah?
Oh
yeah. I have one interesting question. I have no answer, unfortunately. How do you think longevity will affect religion, and what is the future of the relationship between man and the church?
I have a pretty clear answer to that question. I don't think that medicine to keep people healthy is going to have any detrimental effect on religion. If we look back at history, we can see that in many people's eyes, religion depended upon the belief that God created the universe and created life and all that. It was what Thomas Aquinas called the argument from design. But when Charles Darwin came along and completely obliterated that argument, religion did not die. Religion is still with us, alive and kicking. And I think that's going to be the same. In fact, more so, because what we're doing with the developed medicines that keep people healthy is not a paradigm shift in terms of what people will see. It's just medicine. And, medicine from the 19th century and the 20th century didn't challenge religion. So I do not see that medicine in the 21st century is going to challenge it either.
You are right. Thank you.
Great. Let's go to Ilya.
Okay, so Aubrey, you've described previously how a lot of biogerontologists and biologists often refuse to give a prediction for time frames of this sort of technology, or they just give extremely conservative predictions. Like, for example, maybe we'll get 2 years of healthy life extension in the next century. And often they make these very pessimistic predictions because you've said that they are scared of their ideas being perceived as like radical or, weird. So my question is, often in like all of these YouTube interviews, it's basically just you and David Sinclair and like maybe one or two other gerontologists that communicate with the public. There's a lot of gerontologists that we don't see. So my question is, what is the general sentiment among all of the biogerontologists that we don't see, but since you are so involved with the field, you've definitely communicated with tons of other gerontologists. So what is the consensus among those gerontologists? Are they like actually, really pessimistic right now, or are their sentiments improving?
Okay, so I really need to emphasize here that I'm not down on people who don't make these predictions. I want to answer your question at many different levels. First of all, your question is, what do people think when they're speaking privately, when I'm sitting down over a beer with them? And the answer to that question is, by and large, they are more pessimistic than me, much more, but that's because they don't consider it to be their job to come to an opinion on such things. They view their job as plugging away, making progress, and we'll see how long it takes. That's their attitude. So when I say, listen, if we don't make public predictions, people are going to carry on thinking that the whole thing is science fiction, and therefore, they're not going to be in favour of taxpayers' money being spent on more research. They will kind of hear what I say, but they will still be very reluctant to actually act on what I say. I've been saying this for 20 years. In fact, I gave a talk at my very first conference that I ran in 2003. The title of the talk was something like, "The Duty of Biogerontologists to Make Public Predictions of Time Frames." Now, you mentioned David Sinclair. Yeah, he's a good friend of mine and obviously a very prominent guy. But he only started saying, pretty aggressive things like 2 years ago. And I believe that, and this is not because he's a coward, this is because he, like every other prominent gerontologist in the world except me, has had to keep his paymasters on side. He has the misfortune to be a professor at Harvard. And even now, very few people are willing to get out and actually talk about time frames at all. That will change, but it's very hard. But here's the good news. You talked about the people you don't hear about. But actually, they're not the problem. Because, as in any field of science, hardly anybody, the vast majority of the experts hate doing any kind of public speaking to a lay audience, to journalists or whatever. They don't have any training in it, they're not very good at it, and they run away very fast when given the opportunity. It's only a few people who actually get out and do a lot of public interfacing. In gerontology, there's probably less than a dozen of us, right? And we are the people who hold the entire future of human opinion on this in our hands. I've been out there for a very long time saying these things on my own. And I do not define the centre of gravity of this dozen people. But it's only a dozen people. We know each other really well. We know each other's views really well. And even if people are not as optimistic as me, I feel they have a duty to get out and actually say what they do think. And need to take care about what they do think. Things need to change, but perhaps it's not as far away or as difficult as you may have assumed.
Thank you.
Okay, we have 5 more people on the panel, maybe 10 minutes, 10-15 minutes, so we'll try to get through as many people as we can, and then we'll go to the open-end chat after Aubrey and Maria leave. Sam, what's your question?
Can you hear me?
Just barely.
Okay, can you hear me better now?
Just speak as loud as you can.
Yeah, I'll speak as loud as I can. So first of all, Aubrey, I want to say that you inspired me to pursue a career in aging.
Thank you.
And what's up? You can't hear?
I said thank you.
Oh. And I want to ask, do you have any career advice for a first-year PhD student studying aging, interested in getting into the anti-aging industry? And do you have any advice on finding a mentor with a perspective outside of academia, or just a more optimistic view in general?
There's never a quick answer to that question. It's so personal. So it sounds from your accent as though you're American, which means if you're a first year, you're doing rotations. Apologies if I am making a mistaken assumption there. So of course, you're already in a particular institution, and therefore you are having to choose between professors in that institution. However, what you definitely need to be paying attention to is that you don't need to restrict your field of options to people who call themselves gerontologists. There are plenty of people working in many other areas of biomedical research, in particular many areas of regenerative medicine, who do not have the biology of aging as their main focus, but whose area of expertise and research is nevertheless highly relevant. The only real advice I can give you is send me an email, and we will work with your particular situation rather than me trying to guess.
So that's a great question, actually. How do people follow up with you? Can they just email you directly? Do you get just a crazy volume of email and you can't respond? Or I know you're very responsive on your emails in general, but what's the best way for people to reach you?
Yeah, I have one email address, aubrey@sens.org. Everything that comes to that address, I actually read it. Now, you're right, Robert. I don't reply to everything, but all that means is I don't reply to everything myself. When I don't reply, somebody else does. So that is the right way to reach me.
All right, let's go to Creon. What's your question?
Hey, Aubrey. Good to be with you. We're old friends. But I wanted to know, I wanted to ask about Dave Sinclair, if you have anything to say in particular about, one, his general principle, at least as put forth in his book, as I understand it, and then two, his particular claim, which I do not understand. So I understand his claim that DNA methylation is very important and turns all sorts of things on and off, and if your DNA methylation starts to get errors in it as you age, it's going to have huge downstream effects on gene expression and then everything else. What I do not understand is his contention that somewhere within the body there is a pristine copy of the methylation information that can somehow be used to correct all the erroneous methylation in various senescing cells. Do you understand that?
Yes and no. So, okay, first of all, I'm quite sure that most of the people on this call will have less of an understanding of what David is proposing than you do. So let me give a bit of background.
Yes, please.
David has put forward this thing that he likes to call the information theory of aging. Now, first of all, we have to understand what is a theory of aging at all, and that's not obvious. So let me be very clear about this. A theory of aging is the contention that such and such a mechanism of damage creation is the dominant mechanism that makes us get sick late in life. We all agree that aging arises from the lifelong accumulation of damage that eventually exceeds the amount that the body is set up to tolerate. I do not have a preferred theory of aging. Rather, I have the opposite situation. I believe that multiple different mechanisms and multiple different types of damage become health-threatening and then life-threatening at roughly the same chronological age in most people. So I'm kind of an anti-theorist of aging, if you like. And I get rather pissed off when people call SENS a theory of aging. Which
well, also, you don't postulate, therefore, some sort of single magic bullet that can stop the whole process.
Or even a or even the dominant one. That's right, quite right. So, David is putting forward a particular theory of aging, which is that especially the mobility of transposable elements, but other reasons as well that cause mutations in the DNA are actually mainly responsible for aging, not by virtue of mutations themselves, but by virtue of epimutations, in other words, random changes to the epigenetic state. Now, this is quite plausible that this happens, that nearly all the time when DNA damage occurs, a mutation does not occur. The pre-mutagenic lesion is repaired properly in terms of the sequence of the DNA. But the mechanism of that repair may nevertheless erase and irreversibly erase certain epigenetic aspects of that region of the DNA. Now, what he has not yet shown is that this is a major, let alone the dominant, mechanism of damage accumulation in DNA, let alone damage accumulation overall. And I want to tell you that I believe he really, probably shouldn't have gone out and talked about this so confidently on the basis of the data that were available. I don't even think the data he's been able to produce in the meantime justifies that. Nevertheless, it's a theory. But your question is a very subtle one. Your question is, what can we do about it, and what does he say we can do about it, and how does that make sense? Now, I'm kind of, speaking off the cuff here, because this is not something that I have actually sat down with David over a beer and understood from his mouth. But I believe that when he talks about this pristine copy, he does not mean a pristine physical copy. He means a pristine algorithm. So in very much the same way that we understand that the Yamanaka factors will restore cells to a state very similar to the embryonic stem cell, by wiping stuff out. That's not the point. The point is what embryonic stem cells do next. And that, of course, is written in the genome, as well as the epigenome, but mostly in the genome, in terms of the program that goes from there to the various lineage committed cells and differentiated cells that happen thereafter. So I believe that what David is actually thinking and kind of saying is that the pristine copy is a pristine copy of the information to make a copy.
Right, but do you think he could possibly be saying something so simple as if you do Yamanaka factors or somehow dedifferentiate cells back to stem cells, or just go look at a stem cell, it will have the pristine copy of the methylation, and if you could only repropagate that to all the differentiated cells, you'd be in business?
Well, that's kind of what I am saying, that there is no such thing as a pristine copy of the methylation, because the pristine methylation state of one type of differentiated cell is very different from the pristine differentiated state of another differentiated type of cell. And therefore there has to be an algorithm that goes from one single methylation state, which is very little methylated at all, namely the embryonic stem cell state, out to these various different, equally pristine, but different differentiated states.
So this is getting pretty technical. Maybe we can hold until hopefully that gives us some sense of what your answers some of your question here. How are we doing on time, Aubrey, Maria?
Yeah, I should probably go in 5 or 10 minutes.
All right, so let's try one last question from the audience, Carrie, and then I'll have a very quick question for you before we wrap it up.
Okay, last question for Aubrey. Thank you for answering our questions today. I definitely look up to Aubrey. You got me interested in anti-aging. I hosted a longevity conference in Vancouver a few years back, and I invited you to speak. Don't know if you remember. You've been traveling lots of places, so I'm the president of the Lifespan Society of BC. But I'll quickly get to my question because I know that.
I remember you. I remember what you and Keegan did in overturning the anti-cryonics legislation up there.
Oh, you do remember. That's nice. So basically, you made a tweet recently that was making the rounds on the internet. Basically, I don't have Twitter. However, I did see like people had screenshot your tweet and they were posting it on Facebook and it was going viral. And I was actually very interested in sort of like you explaining this stance you have from your recent tweet that said, I now think there's a 50% chance that we'll reach longevity escape velocity by 2036. So is this sort of an updated viewpoint, or is this sort of a viewpoint you've held for a long time? Like what kind of a breakthrough or technology that you observed that sort of made you believe that this was possible by that date?
Yeah, it's not a big change in my opinion, no. I've been updating my sense of how soon we would reach longevity escape velocity for nearly 20 years now. I think when I first defined the term back in, I think, 2004, I made a prediction, and it was that we were about 25 years away. So that would take us out to 2029. Over the next 10 years, let's say, until 2014, that flipped quite a lot. We were making probably less than half the rate of progress that I had predicted. But the good news is the only reason we were making such little progress was lack of funding, which of course has increasingly ceased to be a problem, though certainly not completely, as a result of the emergence of the private sector. But the long and short of it is that my timeframes have not been slipping very much since then. In the past, let's say 5 or 7 years, now I'm going to say 5 or 6 years ago, I was probably saying 2034, probably 2035 even, and so it's hardly slipped at all since then. No, the only reason I did this tweet was because someone wrote to me and said that they would bid on it. They would use it as one of these non-fungible token things that everybody seems to be talking about now. So they said, please say what your latest prediction of that kind of thing, and I will put a bid on it or something like that.
Oh, so if they made a smart contract, so if you're correct, they would pay out cryptocurrency to SENS, and if you weren't correct, they would just keep it? Something like that?
I don't think it was a smart contract thing. If that's all it was, I'm rather pissed off because, of course, that's not going to happen for another 15 years, which is, I want money a lot sooner than that.
Yeah.
But yeah.
Yeah, actually, my husband made an NFT for SENS, a group of NFTs a couple years back, and it was a fundraiser for SENS. I don't know if they're still floating around, but it'd be kind of interesting to see how much they would cost now.
Yeah, so I don't think this is any kind of smart contract thing. I think it's purely something that people are auctioning in the same way that Jack Dorsey's first tweet is sold for $2.5 million or whatever.
Okay, so on that note, maybe we can get through some very quick questions before you have to go. What can people do to help you and the organization?
So everyone's got the different things they can do. If you have any money to spare, send it to us. If you want to organise something for me to do a talk like this, do that. If you're a journalist, if you have a podcast, I'm all that. But of course, everybody can do advocacy in their own way. Everybody can go out and talk to their friends and their colleagues and their family and educate them and get the quality of people's understanding of this and their enthusiasm for it higher than it currently is. That's really big. For more specific questions, obviously, we have a lot of information on our website at sens.org, but equally, anything you want to know, write to us. We have a contact form there. I see every single email that comes through, and it gets answered. We're very well behaved about that.
Okay, and who do you want to see on a similar Q&A? Who would you yourself want to see for us to interview?
Joe Biden.
Okay. We will do our best. We will do our best. Final question before you have to go.
Let me elaborate, because what I really want to point out here is that now is the time when it has become possible to influence public policy. Historically, it was a complete waste of time, because as we all know, our elected representatives have only one goal in life, which is to get re-elected, and therefore there's no point in trying to persuade them to do something, to spend taxpayers' money on anything that they don't think there are votes in. And, historically, that's been the problem. We have not had the public on our side, but that is increasingly changing, and some of the more enlightened people within the Beltway and elsewhere are beginning to see it. So, we need to be thinking in terms of how to influence public policy.
All right, if we get Joe Biden on the show, you owe me a beer. Deal?
Deal.
And that's the last question here is, what is your favorite beer?
Oh, I definitely don't have one of those.
It's the one he has in his hand.
First time I came to the US, which was probably 30 years ago, it was impossible to get a beer that was remotely worthy of the name. But of course, the microbrew revolution has happened in the meantime, and so it's I find this to be a perfectly acceptable place to live.
All right, we want to thank you and Maria very much for taking the time to come on for the Q&A today. To remind everyone in the audience, we're trying to do this every week. So please follow Nathan and I on Clubhouse and on Twitter, and go to longevitybiotechshow.com for updates. We will be posting the recording, show notes, and announcements and other things shortly. Thanks again, Aubrey and Maria, for your time.
Thank you, Robert. Thank you for the wonderful event and for promoting our important work. Really appreciate it.
Yes, thank you, Robert, Nathan, and Maria, of course.
Okay, and for anyone who wants to stay on after Aubrey and Maria leave, we're going to turn it into an open-ended chat. We'll stop the live stream recording, so you don't have to worry about what you say, and we will keep the conversation going here as long as people want to go. So on that note, Aubrey and Maria, feel free to leave quietly whenever you prefer, and hopefully we can continue the conversation in the future.
Absolutely. Bye-bye, everybody. Thanks for coming.
Thanks.
Thank you.
Just quickly, what was that? Was that a website that Aubrey mentioned, or an email? What was it again?
So Aubrey's organization is the SENS Research Foundation. It's at sens.org, SENS, stands for Strategies for Engineered Negligible Senescence.
Oh, yeah.
And
was there anything else besides that or was that it? I'm sorry, I wasn't able to catch that.
No, it's...
Was that he said he reads all...
Yeah, you can email him directly at aubrey@sens.org.
Oh, okay. I got that. I appreciate that. Thank you.
No worries. All right, Nathan, I'm going to take a short break here, but I will keep the... I'm going to close the live stream. Let me do that now. All right, the stream is off.